in the diagram below, what is the value of W? Now, if you look at this diagram closely, see that we have a uniform beam, and then this is the pivot or the fulcrum about which the beam or the bar can rotate, and this is the center of gravity, which is W. Now, and this is another support here, upward support with a string attached, and the tension of the string is 20 Newton. Now, from the string to the fulcrum is 1 meter. For the string to the center of gravity of the bar is also 1 meter. And from the center of gravity to the end X is 1 meter. We are asked to calculate the weight, which is W, of the bar or of the rod or of the beam. Now, let's go. We need to look at principle of moment, which states that total clockwise moment is equal to total anti-clockwise moment about a particular point. Now, this is the support, that's a fulcrum. The body tends to rotate downward about this point. The body tends to rotate, the entire rod tends to rotate downward about this fulcrum, while this string tends to pull the body upward with respect to the fulcrum. Now, since the body is in equilibrium, it means the total downward forces is equal to the total upward forces. Now, one upward force is available here, which is the tension due to this string, tension T due to the string, and also one downward force is available, which is the weight of the rod itself. So what we are going to do now is to calculate the clockwise moment. With respect to this fulcrum, the force that tend to cause the body to rotate downward, that is to rotate clockwise,ly when the body moves downward, then it generates clockwise moment, and that force is due to the weight of the body. So clockwise moment therefore is due to the weight of the body, and that is given by the product of the weight and the perpendicular distance between the weight and the fulcrum. So this is the fulcrum now. From this place to this place is the distance we are going to use. So the distance is 1 meter, 1 meter. So that is 2 meters. From this place, this fulcrum here, to this place is 2 meters. Right? That's 1 meter, 1 meter. So clockwise moment due to weight is weight W times 2 meter times 2 meter. Right? Now, W is in Newton. The next thing is to determine the anti-clockwise moment. Now, the anti-clockwise moment is due to tension T in the string. We tend to pull the rod upward. The tension T tends to pull the rod upward. So, and the moment generated by the tension is going to be tension T times, multiplied by the perpendicular distance between the string and the fulcrum. So from this fulcrum to the string, the distance is 1 meter. So we multiply tension T, which is 20 Newton, by 1 meter. Right? Multiply 20 by 1 meter. So we have the clockwise moment to be W times 2, okay, which is equal to 2W, and then we have the anti-clockwise moment to be 20 times 1, which is still equal to what? 20 Newton meter. So that is the anti-clockwise moment. Now going back to the principle of moment, we have that total anti-clockwise moment is equal to total clockwise moment, which means this is clockwise moment, which is 2W, we go to 20. So that means W, therefore, because we divide both sides by 2, so W is going to be 10 Newton. So that is the weight of the rod, or just let's say the value of W is 10 Newton. Right. Now we should always remember that whenever we are asked to calculate value of a particular force, it's always important to remember the principle of moment. The principle of moment, which states that total anti-clockwise moment is equal to total clockwise moment about a given point. And then to calculate moment, you need to pick a force and then multiply it by the perpendicular distance between that force and the fulcrum. Each force will generate a moment which is given by the product of that force and the perpendicular distance from the fulcrum. The product of the force times perpendicular distance from the fulcrum. Remember, this force T, which is acting upward, will generate anti-clockwise moment. Alright, we tend to lift up the bar with respect to the fulcrum, and therefore it generates anti-clockwise moment. Whereas force W will push the rod down and therefore tend to generate clockwise moment. So when we calculate our clockwise moment and then the anti-clockwise moment, then we must equate them to be able to solve for W. I hope you have enjoyed this tutorial video, and I thank you for watching. I would like to see you in my next video for another work example. Thank you very much.